ways are there to solve math?
Many!
Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself.
So the second equation for solve perimeter is?
2 times length plus 2 times width.
Welcome to the elementary edition of Count on Us. I'm Miss Shirey.
I'm Mr. G.
And we're here to help you with your homework today.
Call us up.
Call us up. We hope you have a lot of homework. We're here to work on the hardest problems that you have. 301-772-0080.
You hope they have a lot of homework?
I do.
Okay. I guess I do too, because then we're in business.
I know. I gave my kids a lot of homework.
You did?
Oh, yeah.
Oh.
Yeah. You have a lot of things to learn. A lot of things to brush up on, you know. It's going to be the holiday season soon. People are taking a break. But for now, you need to stick to those studies.
Okay. So call in at 301-772-0080.
Absolutely.
And then after we help you with one of your homework problems, you can take on a challenge.
The challenges today, what are they, Mr. G?
Well, we have our 24 challenge.
We have card A, card B, card C, and card D. In each card, you need to use each of the 4 numbers one time to make the number 24. So we hope that you're writing these down, and during the show, you can call us in and figure out one of our challenges. For example, card A has 5, 5, 4, 1. Now, you can use the 5 twice because it's listed 2 times on the card. Card B, 4, 4, 9, 1. That's a 9 because it's filled in with the red.
And C is 6, 6, 2, 4. And D is 3, 7, 2, 6.
Excellent. So copy those down, work on those at home. And then when you're calling in for your math homework, which I know you have a lot of, then you can solve one of our challenges. We also have a challenge of the day, a problem of the day.
Ooh. How much dirt is there in a hole that is 6 feet deep and 10 inches in diameter?
It's a difficult one. I don't know.
That's interesting.
Leave that up there for a second there.
It's a meaty one.
Think about that. Wow. Well, work on that one as well. You can work on either the 6 feet deep problem or, of course, our Challenge 24 cards while you're waiting to answer the other questions. Yeah, Mr. G, how's it going today?
Great. I just answered one just while you were asking me that question.
See,
I answered
it's so
B.
addicting, the Challenge 24 cards. You can figure them out in your head using mental math. So what are you working on?
Well, I was working with 6th graders today, and they were doing some division problems and word problems. Yeah, and some of them are kind of scared of the division, but I told them division's nothing but sharing
That's it.
equal groups. That's all it is.
A little bit of sharing.
So we did a few of those problems just to get used to it because they get a little challenging when it's a 3-digit dividend and a 2-digit divisor. So then it gets a little intimidating.
It's okay. It's all right. It's no big deal. We actually did some word problems today in 2nd grade. We did 2-step word problems.
Ooh.
Yeah.
In 1st grade?
2nd.
2nd grade? Wow.
So some of them were add, some of them were subtract, and some of them were add and subtract.
Okay.
So it was, you had to figure out what you had to do and when and how to figure it out. It was pretty challenging.
Yeah, the main part is understanding what's being asked.
That's right.
And knowing what steps to take to solve it.
Absolutely. Absolutely. Like, let me give you an example.
Please.
So let's talk about you, Mr. G. Mr. G had 22 marbles. You had 22 marbles.
Okay.
And you lost some. He lost 7 marbles. Okay. Then he bought 18 more. How many does he have now? Yeah.
Oh, wow. That's a whopper.
Yeah.
That's a whopper. There's a
Not
lot
really.
going on there.
Not if you break it apart like you just said. What do we know? What do you know, Mr. G?
Well, I know I had 22 marbles.
Right, you had 22. You started with 22. What else do you know?
And then I lost 7. Ooh, I
You
hate
lost
losing
7.
stuff.
What happens when you lose, Mr. G?
Well,
You get
that's like
more
a
or
subtraction
less?
problem.
Oh, okay. Well, I
So
taught my
those
kids.
are gone.
Taught my kids to put a little minus by that part of the problem.
Oh, okay.
Then what happened?
Then I bought 18 more.
When you're buying more, getting less.
You're adding.
Oh, so I told my kids just put yourself a couple of notes there. So my question is, how many does he have now? How many do you have now? That's what I'm trying to figure out. So obviously this is a minus then a plus problem.
Right.
So we already know what to do now because we took our little notes in the problem. 22 minus 7. Can you do 2 minus 7, Mr. G?
No, you can't. So
next
you're going to have to borrow from the tens place and grab a 10 and turn it into 10 ones.
That's right. If we do
And
that.
then put the 10 ones with the 2 ones that are already there. Now you have 12 ones. You take away 7 ones because
And
you
you
have
have?
Now you'll be left with 5 ones.
And 1 minus
And there's
nothing.
1 10 there, so you have 1 10 still. And then you still have 15.
Okay, so you had 15 even after you lost some.
Right. So then
so
I
you
go to
still
the
have
store
15.
and I can get them at the dollar store for $1.
Oh yeah, awesome.
Plus a little tax. so
18
it's like $1.06.
for $1. Hey,
There you
that's
go.
awesome.
So then 18. So I have 8 plus 5. That's going to give me 13. So
Leave
I'm going
my
to put the 3
ones.
down there. And then 1 goes in the 10 column. And then that's a 10. So 10, 20, 30. Ooh-wee. So I have 33 marbles.
33
And if I
marbles
didn't
now.
lose the 7, I would have 40 marbles.
But you're always losing your marbles. Always losing them, Mr.
I think you
G.
set me up for that one. Wow.
That was a great problem.
Mr. G's always losing his marbles.
So that's what we were doing, 2-step problems. But it's really not bad if you take notes, just like Mr. G and I did. You go through and you figure out what do you know, what do you want to know. Just use your strategies. But I think we have a caller.
Do we?
We do.
Yes!
It's caller
Yes!
day. Caller. Hello. Welcome to Count on Us. Hello.
Hello, 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 hello. Are you out there? Yoo-hoo.
Hello.
Caller,
We're being told there's a caller. Hello.
caller. Are you out there?
I don't know. We're not getting our caller. I think it's Andre.
We don't hear you.
Hello, Andre.
Caller.
Well, I don't know where
Okay.
Andre is. Is it Devin? Maybe you have the wrong person. Hello.
Hello.
Hello. Welcome to Count on Us.
Hi.
Hi.
What's your name?
Devin.
Hi, Devin. What school are you calling from?
I'm calling from Cherokee Lane.
Cherokee
Oh,
Lane.
Cherokee Lane. Excellent, excellent school. What grade are you in?
5th.
5th grade. Excellent.
Fifth.
Okay, and how can we help you today?
I'm trying to find, I have to multiply fractions.
Ooh, multiplying fractions. Okay. All right. And what problem are you working on?
Well, I have to first turn mixed numbers into improper fractions.
Okay.
Okay. And what's the problem that you're working on?
3 as a whole number and
Okay.
2/3
3 2/3. Okay.
multiplied with 1 as a whole number
Okay.
and 1/3.
1 1/3. Okay.
So you have 3 2/3 times 1 1/3. Okay. Devin, do you know the first step to changing these into improper fractions?
By multiplying the 3 with the 3.
Okay. Do you know why you do that?
Not at all.
Well, if we take 3 whole, that 2/3 is telling us that each of these whole are broken up into 3 equal parts. So here's 1 whole, here's 2 whole, here's 3 whole, and here's my 1 2/3. You see that?
Yes.
Okay. So what happens is when we take this denominator and multiply it by the whole number, 3 times 3 in the whole gives me 9. So here's my 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So they're 9/3 and 3 whole. And then what's the next step?
We have to add it with 2.
Right. So here's my 1 2/3. So when I count all these thirds together, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That gives me 11/3. You see that?
Yes.
They are one and the same. Now we need it 1 1/3 times. So how are we going to make this into a improper fraction?
Okay.
What do we have to do to change this one?
You have to multiply 3 times 1
Okay.
equals 3 plus 1 equals 4.
Okay, so that's going to be times 4/3. So I have 11/3 times 4/3. Ta-da! Now, what do you have to do with those?
You have to multiply.
Okay, so do you multiply 11 times 3 and 4 times 3, or 11 times 4 and 3 times 3?
11 times 4 and 3 times 3.
Great. So what's 11 times 4?
44.
There you go. And what's 3 times 3?
9.
There you go. Now, what kind of fraction do you have? Devin?
Are you there, Devin?
Devin!
Oh, no.
Devin! We lost Devin!
Oh,
Devin, we aren't done. So what we have to do is we have to find how many 9s we can, 9 whole, or 9s we can get from 44. Because 9 ninths make 1 whole. So I know 9 times 5 is 45, so that's not going to work. But 9 times 4 is going to give me what I need. So what I'm doing is a fraction problem is the same as a division problem. So this is saying 44 divided by 9. So if I do that, 44 divided by 9, and I say, can I share 4 tens with 9 people? Nope. So you could put a 0 there. Some people put an X there. And then, can I share 44 with 9 people? Of course I can. And each one will get 4. And I will have shared out 36 of whatever it is that I'm sharing. Uh-oh. Here we go again. 4 minus 6 we can't do, so we have to borrow. So if we borrow 1 10, that becomes 3. And that 1 10 with the 4 becomes 14. So now 14 minus 6 is 8. So I have 8 remainder. So 5th grade, you may be taking the remainder and putting it over the divisor, which will give you 4 8/9. Ta-da! And that's your answer. I mean,
excellent, excellent.
6th grade, you're going to turn it into a decimal
Devin,
number.
you're back?
Yep.
Okay, were you watching while Mr. G was figuring out your problem?
I was watching.
Okay,
Very
excellent.
good. So do you understand how we finished it?
Yes.
Okay, very good. Very good, very good.
Would you like to try one of our challenges?
Yes.
Okay.
Excellent. Which one would you like to try?
Can I try C?
C, okay.
C.
Challenge 24.
All right.
All right, letter C. 6, 6, 4, 2. Ooh, that sounds like a difficult one. All right, anytime you're ready.
6 2 equals 12.
Okay.
Okay. All right.
Adding 6 equals 18.
Okay. 12 plus 6 is 18. All right.
And then we add 2, and that equals 20.
Well, we already used the 2. The only thing we have left to use yet is the 4.
And now we add, after it's 18, we use the, if we add 4,
Okay. 18 plus 4. Where do you come from? Oh, I think you're very close. You're very close, Devin. Good try. Good try, Devin. Mr. G, Mr. G. Good try. All right, we are so awesome. That's awesome that you called back in, that you wanted to solve one of our challenges. We're super proud of you. Thank you so much for calling, Devin. We are going to put your name in the treasure chest.
Woohoo! Treasure chest.
And you might be the winner at the end of the show. Okay, stay tuned. Thanks for calling, Devin.
I think we need a song for our
I think we
treasure
lost. We
chest.
keep losing people. I don't understand what the problem is, but I'm hoping we're not going to lose our next caller. Hello. Welcome to Count on Us. Who's there? I hear someone.
Andre, turn your TV down because we can hear you on your TV. You have to talk to us on the phone and turn your television all the way down.
oh,
Hello? Hello?
oh,
Hi, Andre.
hi,
Hi. What school are you calling from?
Carrollton,
Carrollton?
yes,
Okay, great. And what grade are you in?
5th,
5th grade. Excellent. And what are you working on this evening?
I'm working on 6 numbers.
Mixed numbers?
Okay.
Okay. What kind of mixed numbers? What's your problem?
I'm trying to, I'm doing fractions.
Okay. And what's the specific problem you're working on tonight?
Working on 1, 7, 12.
1 and 7/12?
Yes.
Okay.
And what are you doing with that 1 and 7/12?
Trying to divide it.
Okay. Divided by what?
Divided by 3 fifths 8.
Can you repeat that?
Huh?
Repeat the number again. You're dividing it by what?
3 fifths 8.
3 and 5/8?
Yes.
Oh, 3 and 5/8. Okay.
Does that look right?
Yes.
Okay. So, do you know the first step?
Huh?
Do you know what you have to do here at all?
No.
No? Okay. Do you know how to turn a mixed number into an improper fraction?
No.
Okay, so the first part is this one whole is broken up into 12 equal parts. So there's 12 whole in there. So that's why we're going 12 times 1 is 12. And then what's 12 plus 7?
18.
No, not 18. $19.
19.
All right, now let's do the same thing over here. What's 8 times 3?
24.
24 plus 5?
29.
Okay, so that's 29 over 8. Now, what happens here? Do you know what the next step is?
No.
Okay, so did you talk about inverse relationships yet in class?
No.
No? So your teacher didn't talk about changing the division to multiplication?
No.
No? Okay, so what happens here is we're going to keep the 19/12.
Okay.
We're going to change the division to multiplication. And we're going to flip the 29/8 to 8/29. They have what's called an inverse relationship. And we can do that because they'll equal 1 when we put them together. Did your teacher talk about that at all today?
Yes.
Okay. So is this a problem that you made up, or this is a problem that was in your book?
It was in my book.
Okay. All right. So did you talk about simplifying first before you work the problem out?
Yes.
Okay. So can you simplify 19 and 8? Andre?
Yeah.
What are the factors of 19?
2.
2 times what equals 19? All right, so you have to, 19 is a prime number. So in this case, 19 only has 1 times 19. 2 only works with even numbers. 2 is only a factor of even numbers. That's it. 8 has 1 times 8 and 2 times 4. They don't have anything in common, so you can't simplify those. And those you would multiply across anyway. You wouldn't simplify those. But you can simplify the 8 and the 12.
Oh.
So what do 8 and 12 have in common? 1 times 12, 2 times 6, and 3 times 4. What do they have in common, 8 and 12? They both have 1, right?
Yes.
Okay, Andre, turn the television down and listen to me on your phone.
Okay.
They both have 2, correct?
Yes.
They both have 4, correct?
Yes.
So what's the biggest number that they have in common?
3, 4.
4. So that means we can divide both of these by 4 and change this to make the problem smaller. So 8 divided by 4, 8 divided by 4 is
2.
2. So that becomes 2. And 12 divided by 4 is
3.
3. Now why do we do that? Because before it would have been 19 times 8 and 12 times 29, which would make your problem very big. But now we made it smaller by simplifying it, using the greatest common factor. So now, what's 19 times 2?
38.
There you go. And what's 29 times 3?
78.
78?
Yes.
No. Got the
17.
numbers. You got the numbers mixed up.
87.
There you go. 87. Now the question is, can you simplify that?
Wow.
I'm willing to bet that 87 is prime and you can't.
Okay.
But you could check.
Okay.
All right? Does that help you?
Yes.
All right. So use that example to answer the rest of your homework problems, okay?
Okay.
Very good, very good.
All
Are you going
right.
to take on the challenge?
24.
You want a 24 challenge?
Okay.
What you going to shoot for today?
A.
Okay.
Card A.
5541. Anytime you're ready.
Five times 4.
5 times 4 is
20.
20. Okay.
20 plus 5
Equals
25.
Good job. Okay.
25 plus 1.
What was that last part?
1.
Couldn't hear what you said.
What operation are you doing with the 1?
To times.
25 times
25
1?
times 1, you said?
Yes.
Okay.
Oh, 25 times 1. What does that give you?
25.
Ooh, 25. So close.
What was your target, Andre? What were you shooting for? Supposed to try to get 24.
Oh,
Yeah.
24.
Very close, very close, very close.
Good try, Andre. Well, we're going to put your name in the treasure chest, okay? Thanks for calling. Hopefully you'll be our winner at the end of the show.
Woo!
All right. We're going to move on to our next caller. Hello. Welcome to Count on Us.
hi.
Hi, who is this?
Huh?
Who is this?
My name is Sona.
Hi, Sona.
Hey,
Welcome to the
Sona.
show. What school are you calling from?
Carrollton Elementary School.
Oh, wonderful. And what grade are you in?
5th grade.
All right. Are you also
Carrollton's
working on
working it out.
fractions?
Yes.
Okay. What problem are you working on tonight?
2 wholes and 1/6 subtracted by 1 whole and 5/6.
2 and 1/6 minus, what was the last part?
1 whole and 5/6.
And 5/6. Excellent problem.
Wow, they're doing they're subtracting them, they're dividing them. Okay,
They're doing
all
everything.
at once.
All right. How would you start?
My teacher told me to rename them, but I forgot to rename. I don't know. I forgot how to rename them.
Okay. Well, I'm going to write it vertically so it's a little easier for us to rename. Okay?
Okay.
So what are we going to do first? What are we going to try to subtract first? Well, Sona, if you have 1/6 of a pizza, can you give away 5/6?
Huh?
If you have 1/6 of a pizza, can you give away 5/6?
No.
No, you can't. That's right. This is like regular subtraction at first. If I cannot do 1 minus 5, 1 piece minus 5 pieces. I can't do that. So this is what your teacher was talking about when she was saying renaming. Just like in borrowing with subtraction, we have to go next door to the whole number and we have to borrow from that whole number. So what whole number is next door?
2.
Right, 2 wholes. Okay, so if we borrow a whole, there's only going to be 1 more whole left. That's the same as we are working on in regular subtraction, but the difference comes when we try to rename the other fraction. Okay, when we borrowed this 1 whole, we took over a piece and we wanted to cut it up into the same size pieces that we had here before. What size pieces did we have before?
6.
Right. So 1 whole would be the same as 6/6. Does that make sense? When the numerator and denominator are the same number, that is the same as 1 whole. So if I bring over 6/6, I already have 1/6. How many is that altogether?
That's 2 and 1/6.
Well, we had 2 and 1/6. Now we brought over one of the wholes. Here it is. It's like a fancy 1. That's all it is, another name for 1 whole. And I want to put these 2 pieces together. So what's 6 plus 1?
7.
Right, because it looks like this. 6/6 plus 1 more 6th would be 7/6. Okay? So now we have 7/6 over here. And I'm just going to bring this over here. the 5/6, so it's easier to see. 7/6 minus 5/6. Can we do that?
2/6.
Right. Now it's 2/6. Very good. Now let's go back to our whole numbers. Now we don't have 2 wholes left over here, do we?
We have 1 whole now.
We have 1. Excellent. So 1 minus 1.
0.
Right. So we don't have any holes left. But we do have 2/6 left. Now the problem with 2/6 is that it's not simplified, right?
It can be simplified to 1/3.
Oh, very good. Divide the top by 2, divide the bottom by 2. That's like dividing it by 2 halves, divided by 1, 1/3. You got it. I think you know how to do these. Excellent work, Sona. Would you like to try one of our challenges?
Yeah.
Okay, what challenge would you like?
Challenge 24.
All right. Which problem?
Challenge A.
A, 5, 5, 4, 1.
Again.
Okay. Anytime you're ready.
Okay, let's see. 5 times 4 is 20.
All day, every day.
Okay. Next.
20 plus 5 is 25.
Next.
And 25 minus 1 is 24.
Excellent! Excellent job, Sona. A perfect winner.
Sona has her name in twice.
Once, twice. We're putting your name in the
Slam dunk.
slam dunk in the treasure chest 2 times. Thank you so much for calling, Sona. And right now, we are going to go to a break. But if you're on the line, please stay on the line. It'll just be a minute or so. Be a little while till we come back. And we are just, we're so ready to answer. We have a lot of calls today.
Go get a snack and come right back.
All right, we'll see you in a bit.
Hi, I'm James. I'm from Tilton Elementary School. I'm here today for the email question of the day. Mary needed to place a fence in her yard in order to keep her sheep in. If her yard is a rectangle with a length of 26 feet and a width of 20 feet, how much fencing will she need? Well, let's take a look. So first, I would draw a rectangle to represent her feet. Then I would draw 26 feet at one side and 26 feet on the opposite side. Then I would draw 20 feet at one and another side, and then 20 at the opposite side to represent the fencing. Since we're talking about perimeter, since I have to do perimeter, I have to add all the numbers. 26 plus 26 plus 20 plus 20. 6 plus 6 equals 12, so I'll put the 2 at the bottom and carry the 1. 2 plus 2 plus 2 plus 2 equals 8. Then I'll add the 1. That equals 92 feet. So the fencing of her yard will be 92 feet. That's it for the email question of the day. Stay tuned for some more on Count on Us.
This is the ocean, and this is Kipper. Kipper doesn't live in the ocean, but if she did, this is likely what would happen. This is Sparky, and this is habitat destruction. Boozer doesn't like it, neither does Fluffy. We wouldn't let this happen to Kipper, Sparky, Boozer, or Fluffy. In the oceans, it's worse. Lacking opposable thumbs, Kipper can't take action, but you can. Visit BeringSeaCanyons.org.
He was so inspiring.
He took chances.
He was so moving.
He lived daringly.
Martin Luther King Jr. was a man of service, and his day shall be a day of service.
He inspired us in words, but he led us in deeds. To honor him, Let's do the same. Go to mlkday.gov and find out how to volunteer on Martin Luther King Day and beyond. This message is brought to you by the Corporation for National and Community.
Okay, guys, ready? Here we go. Let's smile and brush our teeth twice a day, every day. Let's smile and floss our teeth once a day, every day. Let's keep that smile a happy place on your face with good nutrition and dental visits. Let's smile. Let's smile. Let's smile. Let's smile.
Hi, I'm Miss Matlock from Templeton Elementary School, and we want to know
How we smile areas. Thank you.
And welcome back to the second half of the elementary edition of Count on Us. I'm Miss Shirey.
And Mr. G.
We're here to help you with your homework. We're here to help you with your math homework. And you have had a lot tonight. See, my predictions came true. I said they would have a lot of homework, and they sure did.
Indeed.
We've had a lot of callers. But we actually had a little shout out, about area.
Templeton.
Oh,
That was
Templeton.
Hi, Templeton.
Hey! And we want to answer their question about area. They say they want to know something about area. Mr. G.
Area.
Tell me about area.
Area. What is area?
I don't know. What is
Area is the number of squares it takes to cover a surface.
Okay. Squares.
So,
Like
yeah.
square units?
Yeah, you know why? Because they're perfect. They're like boom, boom, 1 inch, 1 inch.
Oh, okay. So these are 1 inch squares. Okay.
Right. So, let's say we have a rectangle. That measures, let's say, 3 by 4 inches.
Okay. 3
Right?
by 4.
So, what I can do is, I can take my squares and I can make some arrays. And if you don't have them, you can just draw them. So, here's 3. Oh, did I do that wrong?
Yeah,
I
you
did
made
feet.
It's okay. I'm going to fix it for you.
1 inch, 2 inch, 3 inch. So, I need 3 of these, but I need it 4 times.
Right, because you need to cover the whole surface.
There you go. So 1, 2, 3.
Okay.
1, 2, 3. 1, 2, 3.
You're almost there.
I have a perfect square right now.
Oh, you sure do.
That's why 9 is a square number.
It is. I know.
Isn't that cool?
I love square numbers.
I do too. 1, 2, 3. So in my rectangle here, I have a 3. Ooh.
It's getting a little messy.
It's getting a little messy. I'm messy. Whenever I work, I'm messy. I'm sure some of our callers out there are messy too.
It's okay.
So 3 by 4. So 3 times 4 is 12. So 1, 2, 3.
Oh, well, guess what? Let me fix your problem here. Ta-da!
Well, that changes a little bit because that's not 3 by 4 anymore. It's
3
4
rows
by
of
3.
4?
But that's cool.
3 rows of 4?
4 rows of 3.
Well, now it's 4 rows of 3.
Or 3
well,
rows
it was
of 4.
rows of 3. Well, we get
3
the
rows of
same
4, okay.
area.
Cool.
We get the
So,
same area.
3. No, duh. I'm still stuck with. So 4 and 3. So
still get the same
what do I mean by 4? 4 columns. 1, 2, 3, 4.
Right.
And 3 rows. 1, 2, 3.
Rows and then columns. So rows and then columns. So 3 rows and 4 columns. 3 by 4.
Got you.
3 by 4.
Yeah, that's me messing up today.
No, it's all good. You get the same area, Mr.
Right,
G.
you still get the same area. So it's 3 rows, 1, 2, 3, and 4 columns, 1, 2, 3, 4. So if you count all the squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 squares that make this up.
that cover the surface.
That cover the surface of this rectangle. And if I traced it, watch this.
Ta-da. Oh, you're good.
There we go. So, bam, there it is.
Yeah, but guess what? When you're like a really smart math student, you can figure out how many squares should be in there.
So what happens is usually you have some problems there and there are no squares there. So a lot of times students try to make the squares, but that's not what's important. Nope. The important thing is that you know that it would be 1-inch squares in there and that there would be 4 across and 3 down and altogether there would be 12 squares in there.
12 square units. Okay. Now if I know my multiplication tables, an area is a snap. Look at
so
that.
That would be 12 inches squared. Ta-da!
Very nice, very nice. That's a good review of area, Mr. G.
Woo-wee!
Well, thanks, Templeton. Thanks for that good little review lesson.
I
we
hope I helped
appreciate your
them out
little
there.
shout out.
Wee-wee!
I'm sure you did. That's great. Okay, I think we're ready to go back to our callers.
Are we? Do we have any more callers?
I think we do.
Callers, callers.
Who's there? Who's there? Who's out there? Hello?
Hello?
Hello. Welcome to Count on Us.
Hi.
How are you? What's your name?
Ariana.
Hi, Ariana.
What school are you calling from?
Cherokee Lane.
Oh, Cherokee Lane. Ariana from Cherokee Lane. Excellent. And what grade are you in?
What grade are you in, Ariana?
Oh, I'm in 5th grade.
6th?
5th. Did you say 5th?
5th.
5th grade.
1, 2, 3, 4, 5.
Okay. Ariana from Cherokee Lane, how can we help you today?
I have a mixed number thing. I have a math problem. Multiplying mixed numbers.
Okay. So give us the problem.
1 and 5/9.
Okay. Times
3 and 2/7.
Complicated problems tonight.
Some ugly problems. They're not nice and easy anymore. No. Okay. So, Ariana, do you know the first step?
You have to change the mixed number into an improper fraction.
Woo-wee! How are we going to do that?
You multiply the 1 times the 9.
Right. The denominator times the whole number. That'll give you what?
9.
And then what?
You add the 5.
There you go. So, 9 plus 5 is what?
14.
There you go. So 14/9. So that one whole is broken up into 9 equal parts, and that's what you're counting in there. And then there's another one that's not quite full, and it's 5/9 there. Now, what are we going to do to this 3 and 2/7?
You multiply the denominator times your whole number.
Which is?
7 times 3.
Equals?
21.
And what's next?
Then you add 2.
Which will give you?
23.
Very good.
Now, we could multiply 14 times 23, which is going to be some really big number, or big in the hundreds, and 9 times 7. You know your 9 times tables?
Yes.
You know your 7 times tables?
Yes.
You know your 14 times tables?
No.
You know your 23 times tables?
No.
Yeah, so what we could do, if we looked at these numbers, we could simplify. Well, you tell me, could we simplify any of those numbers? If you look, 14 and 7, do they have a common factor?
2?
Ooh, no. 2 times what gives you 7?
Oh.
Ah, So a common factor is when you multiply two numbers together, it gives you 7. And when you multiply together, it gives you 14. So do they share a common factor?
No.
Yes, they do. Yes, they do.
Look closer, my friend.
So 14 has 1 times 14 and 2 times 7, correct?
Yes.
7 has 1 times 7. Any more?
No.
No, because 7 is a prime number, so it only has 1 and itself. So now, what do they have in common?
The 1.
They both have 1 and don't look too close, it'll bite you in the nose.
7.
There you go. They both have 7. So that means they share 1, but 1 is not going to do anything. They share 7. 7 is the greatest common factor between 14 and 7. So we can use that common factor to divide those numbers and make them smaller. Did you talk about that in class?
I think so.
You have to pay attention, Ariana. This is important information. So 7 divided by 7 gives you what?
1.
7 divided by 7 gives you 1. 14 divided by 7 gives you
2.
2. We just made this problem a lot smaller now. So now we have 2/9 times 23 over 1. Isn't that smaller?
Yes.
So we can do that. That is absolutely allowable. So now, mental math. What's 2 times 23?
46.
There you go. And what's 9 times 1?
9.
Ta-da. Now, what kind of fraction is 46/9? Dun, dun, dun. It is an improper fraction. I don't like the name improper, but what that means is the top number, the numerator, is bigger than the denominator, which means we can get some holes out of there. Right? You know your 9 times tables you told me, right?
Yes.
9 times what to get you close to 46 without going over?
5.
9 times 5 is what?
45.
So I can get 5 whole groups of 9 out of there, right?
Yes.
And then what's left over?
1.
1. Nice. So your answer is 46/9, and it's equal to 5 1/9. Now, if you did 14 times 23 and 9 times 7, that would have given you some big number, and when you simplified it, it still would have given you 5 1/9. Got it?
Yes.
Does that help you? Does that help you, Ariana?
Yes.
Very good, very good, very good.
Very good. I'm putting your name in the magic treasure chest.
Are you ready for a challenge? Ariana?
Yes.
Would you like to be challenged?
No, thank you.
No?
Oh, not today. It sounds like she has so much homework. She has those improper fractions.
She's going to persevere on her homework.
Yes,
Okay.
yes. That's all right.
Okay,
Thank
Ariana.
you. Thank you.
Your name is in the treasure chest nonetheless.
Yes, and we're going to move on to our next caller. Hello. Welcome to Count on Us.
Who's out there?
Journey.
Journey?
Journey, turn on your
Hello.
TV. Your TV. Your TV. Turn it down. Turn it down. Turn it down. All right, Journey, what's going on? What are we working on?
Simplifying. Trying to find the simplest form of a fraction.
Simplify.
We're
Okay.
simplifying. Okay. So can you tell me, did you tell us what school and what grade you're in? Can you tell us that? Fourth?
Fourth.
Okay, good. Okay, so what's the fraction?
3/8 plus 3/8.
Okay.
3/8 plus, let's do it horizontally. 3/8. Okay, Journey, do you know what to do at all here? There's some fraction marks over there.
What did you say?
I said, do you know what to do at all with this?
What?
Do you know how to solve any of this? Do you know what to do when you had to add fractions with a fraction? Journey, you there?
Yes.
Okay, so when you add a fraction and a fraction, what do we have to do here? Journey?
I don't know.
You don't know at all? You have some
No.
eights over there?
I'm trying to figure it out. They're not labeled.
Oh my goodness.
My goodness.
Oh my goodness.
I'm trying
Oh
to
my
figure
goodness.
it out.
I'm trying to use my math tools here, but my math tools aren't labeled.
Here
So
you
it's
go.
making it
Here
a
you
little
go. Here you
challenging.
go. Here you go. Here you go.
Here
I
we
got
go.
it. I got it. I got
So
it going
what do we
on.
have here? These are eighths?
You got 3/8. There you go.
Okay.
3/8. Okay, I'm trying to find you some more eighths.
So the first part to this is, if something is an eighth, that's like its last name. It's not going to change. But what we're going to do is we're going to add the 3 with the 3. We're going to wind up with 6 of them. So we're going to wind up with 6/8. Ta-da! You understand that part, Journey?
Yes.
Okay, so now what happens is we can
think those
take
are
those 6/8 and we can, what I call it is making the least amount of pieces possible. So with those 6/8 pieces, I can simplify to what I like to say is make the least amount of pieces possible. So we have 6 in the numerator, 8 in the denominator. So what we want to find is, what do these two numbers share that we can simplify it by? Do you know?
1.
Well, if we look at 6 and we look at 8, do you know the factors of 6?
You know the factors of 6? Yes. Okay.
So we have 1 times 6, and what else?
2 times 6.
Not 2 times 6. 2 times what?
2 times 3.
2 times 3. Anything else?
No.
No. Okay, let's go to 8. 1 times 8, we know. And what else?
8. 2 times 4.
2 times 4. Okay. Now, do both of these sides have some number in common?
2.
2. 2 is the biggest number that they share. So that means we can divide both of these by 2. So 6 divided by 2 is what? Journey, 6 divided by 2.
2.
In other words, 2 times what number gives you 6?
3.
Journey, I need you to turn your TV down. Listen to me on the phone. Turn the television all the way down and listen to me on the phone. You there?
Yes.
Okay, good. Now, 8 divided by 2 is going to give you what?
8 divided by 2 will give you 4.
There you go. So, we could change 6/8 pieces for 3/4 pieces. It's just like if I had 10 pennies, I could change them for 2 nickels or 1 dime, right?
Yes.
Same thing.
Well, these are not the ones.
Yeah, we were trying to show you with our fraction pieces here, but these fraction pieces are a little bit challenging today.
Go.
That's it?
Going crazy.
Okay. Woo-wee. All right, so here's my 6/8. 1, 2, 3, 4, 5, 6. And what happens is these eighths are equivalent, 2 eighths are equivalent to 1/4.
Yes.
You see that?
Yeah.
Same idea. So what I said, when you simplify, you're making the least amount of pieces. So here I had 8 pieces. Now I have 3 pieces. That's what happens when you simplify. You got it?
The same amount. Same amount.
Right, it has the same value. They're equivalent. They're equal. Just like I said, 10 pennies is the same as 1 dime. Same idea.
Okay.
All right?
All right.
Are you going to take on a challenge?
No.
No?
No, not today.
Well, I hope we helped you with your homework.
All right. We're going to put your name in the chest.
Oh, yes, yes.
And we're going to make sure you are going to win a prize.
We must do that. Do we
All
win
right.
prizes? Do we get prizes? No?
You get prizes.
We do?
Yes.
I want a prize.
All right. So, Journey, your name is going into the chest, and we're going to call a number in just a name. Not a number, a name.
A name,
I'm
yes.
getting confused with my names and numbers.
It seems to be that kind of an afternoon.
So, do you want to talk about one more fraction problem before we go?
Fraction or another area, since Templeton shouted us out.
Well, let's do another area.
Another area problem.
I have all my fraction pieces here.
You have, oh.
We do have area pieces.
I need my area pieces, though. Okay. So, let's say we have I don't know. Okay.
I think we might have a caller.
We have a caller?
Yeah.
Caller, are you out there in caller land?
Yes.
Hello.
Hi, caller.
Who is this?
Felicia.
Hi, Felicia. How are you? What school are you calling from, Felicia?
Oh, Cherokee Lane.
Cherokee Lane is in the house.
Excellent. And what grade are you in?
What did you say?
What grade are you in?
5th.
5th grade. Okay, and how can we help you today?
Fraction.
What is 1 and 5/10 plus 2 and 2/10? I mean, and then 2 and 2/12.
2 and 2/12, and you're adding them? You're adding them, Felicia?
No, multiplying them.
Multiplying them, okay. All right, so what's the first step?
Adding is okay. It's okay. Oh, okay.
You said 2 and 2/12?
Yes.
Okay. All righty, what's next? Do you know what steps to take?
Yes.
Okay, so 1 and 5/10 is going to become what?
15.
15 what?
15/10.
15/10, okay. Right. And then 2 and 2/12 is going to become what?
26 and 12 and 12.
26/12. Now you could be a super math whiz and do 15 times 26 and 10 times 12, but you can simplify this. Mm-hmm. And because we're running out of time, I'm going to simplify. 15 and 12 have a greatest common factor of 3. So 15 divided by 3 is 5. 12 divided by 3 is 4. And 26 and 10 have a common factor of 2. So 10 divided by 2 is 5. 26 divided by 2 is 13. And 5 times, so that's going to be 5 over 5 times 13 over 4. And that's going to be 5 times 13 is 65. And 5 times 4 is 20. And how many 20s can you get from 65? That's going to be 3. And 5 20ths left over. And you have to simplify that. 5 20ths is the same as 1/4. So that is 3 1/4. Woo-wee! Race to the finish line.
Can I do a challenge?
All right. Well, we don't have time for a challenge. Now we have to pick a name.
That was a challenge getting that in.
All right. Call back, Felicia. Work on it on the intermediate show, okay?
Woo-wee.
All right. Who you going to pick? 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 And the winner is
Devin from Cherokee Lane. Yay!
Thank you so much for tuning in today. I hope we've helped you with your homework. And for Mr. G and myself, remember, you can always
count on us.
Bye-bye.
My name is Mr. Pugh, and I will be talking to you today about constructing a box and whiskers plot. I love constructing box and whisker plots. It's my favorite thing to teach to my students. Now, you know, dealing with box and whisker plots, you must know your measures of variation. There are 5 points that I always tell my students to look out for when constructing a box and whisker plot. And I'm identifying the first 5 for you. But the first 3 are so easy to remember because everyone already knows the first one. Of course, the first part you should look for is your median. It's the median. So I would say, tell my students to write down and identify the first 5 parts. The second part of a box and whisker plot is your lower quartile. The next part is your upper quartile. Now, the best part about this is your lower and upper quartile are just your median. It's the median of the lower set of data. And upper quartile is the median of the upper set of data. And the last 2 points when constructing a box and whisker plot is your lower extreme and your upper extreme. And the final thing with the dealing with a box and whisker plot, a box and whisker plot uses a number line as its graph. So when you're dealing with a box and whisker plot, you must use a number line. It uses a number line to display its data. And it breaks the data up into 4 parts. You should have got the hint when you see the word quartile. It breaks up into fourths. So now, I have a set of data right here. And what we're going to do, we're going to construct a box and whisker plot with the following set of data. So I already identified my first 5 parts. So let's look. So the first thing I'm going to do is construct my number line. I'm going to look at my data. Now, you don't always have to start your number line with 0. I see my lowest number is 26 and my greatest number is 55. So I might start off with 20. I'm going to decide to skip count by 5. I can do 5, I can do 10s, I can do 2s. But if you do 2s or 1s or 3s, your number line will be that much longer. As you see, I don't have that much room. So I'm going to skip count by 5s. And other maths and rules come into play when you're constructing your graph. You want to try to keep your intervals as even as possible. And your intervals are the space in between each number on your number line. I'm doing this freehand, so I'm doing my best I possibly can to keep it even as possible. And there you go. So now, I'm going to first find my median. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 numbers inside this set of data. So what I'm going to do is find, it's 11 numbers, so I know there's going to be one number in the middle to be my median. So I'm going to count the first 5, 2, 3, 4, 5, and count back 5. 1, 2, 3, 4, 5. I noticed there's one number that I did not underline, which was 38. 38 becomes my median. What I'm going to do next is go to my number line and place a point on top of 38. I see I have 35 and 40. I know 38 is a little bit closer to 40, so I'm going to a little bit closer to 40 and put my point for 38, which is my median. The next thing I'm going to do is find my lower quartile. Here's what I'm talking about. That's a big word. It looks different. Don't be afraid of it. It's just another word for it is your median. Lower quartile are all the numbers that are lower than my median. I need to find the median amongst those numbers. So my median amongst those numbers, I have 1, 2, 3, 4, 5 numbers. Once again, it's an odd number, so therefore, it should be one number in the middle. 1, 2, 1, 2, which is 32, which is my lower quartile. I'm going to say L, Q, I'm going to say M for that. So my lower quartile is 32. So I'm going to go to my box, my number line, and place 32 close to 30, but a little bit more, but not close to 35. So next, I'm going to find my upper quartile. The upper quartile are the numbers greater than my median, and I need to find a median amongst those numbers. Once again, it's 5 numbers. The middle number is 51. That's my upper quartile. So my upper quartile is 51. So I'm going to go to my number line and place a point for 51. And I know the 51 is right after 50, so it's really close to 50. Make my points a little bit larger. There you go. And your first 3 points creates your box. So basically, all 3 medians creates your box. So therefore, I'm going to put my box around the upper and lower quartile. Your first median splits the box in half. There you go, right here. There go my box. The last 2 points are the easiest. Oh, you like this. The lower quartile, the lower extreme, it's the lowest number in your set of data, which is 26. So I'm going to put a point on the number line for 26. The lower upper extreme is the largest number in your data, which is 55. Put a point for 55. And 55 is the number on my number line that makes it very easy for me. Now, I'm not finished, because not all box whisker plots will have whiskers. So it's something I have to use or check. It's called an outlier. I have to check for my outlier, which is it's a difference between your quartile, your interquartile range. So therefore, my interquartile range will be 51 minus 32. Now, it's an interquartile range, not the range, but the interquartile range. It's the difference between the highest quartile and the lowest quartile. 51 minus 32, which gives me 19. Now I have to multiply 19 times 1 and 5/10, which gives me 28 and 5/10. So now I have to take this number, this product, and I have to subtract that from my lowest number in my data. I'm sorry, from my lower quartile. What is 32 minus 28 and 5/10? That gives me 4 and 5/10. I have no number lower than 4 and 5/10, so therefore my lowest number 26 is a part of the data. Boom. Then now I have to add this to my upper quartile. 51 plus 28 and 5/10 gives me 79 and 5/10. I have no number larger than 79 and 5/10, so 55 is a part of my data. And we just constructed a box and whiskers plot. And remember, a box and whisker plot breaks data into 4 parts. And the last thing I'm going to show you, look at the 4 parts. 1, 2, 3, 4. And I always tell my kids a quick hint. There's only 5 possible answers for any multiple choice for a box and whisker plot. 0, 25%, 50%, 75%, or 100%. All right? It's like a quick little test taking strategy. I couldn't get that out for a second. All right? And that's been another quick mini lesson here for you. I'm Mr. Pugh. Have a great day.
Minds can achieve anything. We make sure they get to college. Federal student aid provides more than $150 billion in grants, loans, and work-study funds to make college possible for anyone with the mind to get there. Because if given the chance, minds will do great things. Federal Student Aid, proud sponsor of the American Mind. Learn more about money for college at studentaid.gov.
Because how many ways are there to solve math? Many!
Your live homework help starts now. Welcome to Count on Us.
What is the length from the second equation for solving perimeter is
2 times length plus 2 times width.
Hey, welcome back to the second half of our Count on Us show. This is the big time. This is a secondary edition where we have all the middle school, high school, college, postgraduate.
What?
Well, we had the big time questions. Wow, she got me straight already. I'm Ted Herman.
Hi, my name is Miss Walters.
And we're here to answer every math question you might have on your mind.
Yes.
Please call us at
772-0080.
And they can also reach us on the World Wide Web, right, Miss Walters?
Yes, they can.
That's
PGCPS.org. And then click on television services, TV services it is. And you might be a little delayed when you're watching, but at least you can still see us there.
Right.
And get some good information.
And while you're on the phone, please turn your TV set all the way down so we can hear your excellent voice tell us what you want to know.
Right.
And we have a couple of challenges today, Miss Walters.
We do. We have one called Find the Digits. And what it is, you have to figure out what numbers go in these boxes here. It's like finding variables, I guess you could say.
Mm-hmm.
Okay? So make sure you jot down these digits right now. 57 blank. And then underneath that is blank 6 with the 6 in the ones place and the blank in the tens place. Plus 243. And the sum is blank 96.
Oh, okay.
Okay.
And it's addition.
Yes, it is addition. And of course, we have...
Oh, one of my favorite things.
Yes, Challenge 24. Okay, and in this game, you have 4 numbers on each of these cards, and you can do any operation, but your final answer has to be 24. Okay? For card A here, we have 14. This is a 9. When you see a red on the inside here, that is a 9, 3, and 2.
And card B, which is, B, which is down here, is a little tougher than the card A. It only has 1 dot here. We have 2 dots, a little more challenge. 7, 1, 5, 4.
Card C has a 7, a 6, 8, and a 2.
And I have to say card D is the toughest of them all. 3 dots, 5, 2, 8, 8. So you'll need a little extra time figuring that one out.
Right. So make sure you jot down these numbers, because after we talk to you about the math problem that you have, you can give us your solution to the challenge, but you need to have it done so that we don't keep everyone on the lines waiting a long time, okay?
Very good. And speaking of on the lines, we have a lot of callers already tonight.
Wow.
And I'm very excited to turn the first one over to you.
Okay. All right. Hello, caller.
Hello.
Hi, who's this?
Aaliyah.
Hi, Aaliyah. How are you today?
Good.
Good. What school are you calling from?
Fort Foot Elementary.
Fort Foot Elementary. Do you know Mr. G?
Yes.
Ah, he just left. You just missed him.
Oh, my
But
goodness.
I'll be happy to help you anyway.
Hey, you know what, Aaliyah? I like your hair. Looks terrific.
He's so silly. Aaliyah, what can we help you with today? Aaliyah?
At least she passed out.
Aaliyah. I think she may have dropped accidentally. Yeah,
still
maybe
like
she'll
her
call
hair.
back. Maybe she'll call back.
I'm
Call
sorry.
us back, Aaliyah.
Hope we
Okay?
didn't scare her off. She'll call back later, I hope.
Okay.
Well, next caller out there from Charles Carroll Middle School, I believe. Who's that? What's your name?
Mohammed.
Muhammad, how you doing, buddy?
Fine.
What grade are you in?
8th.
And who's your teacher out there, Charles Carroll?
Mr. Hawkins.
Very good. All right, and what kind of class is that? Is that algebra, geometry, or what?
It's algebra. I'm working on dilations.
What's a dilation all about?
I know that to dilate an object, it means to enlarge the size of an object,
Exactly.
or to reduce the size of an object. So I want to know, how do you reduce it or enlarge it?
Ah, well, why don't you give us the problem you have, because it has something to do with a ratio, I'm sure.
Okay, say I have a coordinate grid with the coordinates of 4, 6, 10, 6, and 8, 12, and I want to know how to reduce the size of that figure.
Excellent. You know what's great about Muhammad? He knows exactly what he's doing with this problem.
I really like that.
I like that too. Well, let's go ahead and try to create a coordinate grid the best we can. So,
let me see if we have a chart paper.
Do we already have a coordinate grid someplace? That'd be unbelievable.
I don't know. Let's see.
But if we don't, then we'll go right to the origin, which is 0, 0, and we'll just try to create one as quick as we can.
Okay.
So that all our callers can watch what's going on here. So a coordinate grid is made up of an x-axis, right, Muhammad?
Yeah, and a y-axis.
A y-axis. Beautiful. You know your stuff. Okay. You know what? We're going to need more room than that. So I went really right in the center, so I better bring this down a little bit and give us some more room to work. And since there's no negative numbers, I'm going to bring that x-axis a little lower for us. So here we go. And we don't even have any negatives, so 4, 6. We have 4, 6, which means we go 4 where? Which way do we go on the 4?
4 across and 6 up.
Yes. And what I can tell my students, Muhammad, you don't need this, but I say when you go visit somebody in a big hotel, you got to go across the lobby and then up the elevator. So we went across 4, and now we're going up 1, 2, 3, 4, 5, 6. So that's our 4, 6 point. 10, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then up 6 the same level. So we have 10, 6. And then we have 8, 12. Whoa. 1, 2, 3, 4, 5, 6, 7, 8. And then up 12. Here's 10. Here's 6, 7, 8. Wow, it's way up off the charts. And so basically we have a what shape, you know?
Like a triangle.
Excellent. Just like a triangle. And there's our last coordinate point, 8, 12. And you're saying you want to know how to reduce it down to its lowest level? Is that what you said?
Yeah.
Okay, well, you know what, Muhammad? Let's look at all the numbers and see if they have some kind of relationship, something in common. 4, 6, 10, 6, 8, 12. Can you think of a number off the top of your head that divides into all 6 numbers?
Uh-huh.
What number would that be?
Can you repeat that question again?
Well, looking at the 4 and the 6, do you know a number will fit into 4 and 6?
No.
Well, 4 divided by something and 6 divided by... Oh, Miss Walters is going to save the day. She's making some kind of a cool chart. But think about what number divides into 4 and the same number fits into 6.
2?
Yeah, oh my goodness. He got it. So 4 divided by 2 is what?
2.
Yes. And then 2 divides into 6 how many times?
2.
No, 2 times what makes 6 though?
That's a 3.
Yes. So now we've reduced the 4, 6 down to a lower level of 2, 3. We simplified it, okay? And in a second we're going to have a chance to see Miss Walters' outstanding chart. 8 and 12, let's do the same thing. 8 divided by the same 2 we used is what?
8 divided by 2 is 4.
Right. So we have 4, and what's 12 divided by that same 2?
Is 6.
So now we've translated or made the reduction or simplified down to 4, 6. And then 10, 6. Let's do 10 divided by 2, which is?
5.
Nice job, Muhammad. And then 6 divided by 2 is?
3.
And you know what? This only is true. You did a great job, but it's only as true if that's as low as it can go. Can we fit any more numbers inside 2 and 3? Is there one number divides into 2 and 3 at the same time?
Yeah.
What is it? I mean goes in without any remainder, or no leftovers.
Yeah.
Well, if we go divide 2 by 2, we get 1. Will 3 divide by 2?
Yeah, I think that's 1.5.
Yeah, but we can't use decimals or leftovers, okay?
Oh, okay.
So we're going to keep it the way it is. 2, 3, low as you can go. 4, 6 could go lower, but we got to make sure all 3 coordinate pairs go lower. So we're done. So now 4, 6 has become what? 2, 3. 8, 12 has become 4, 6. And 10, 6 has become 5, 3. And look at Mr. Walters. We're going to bring that over here. That's a great visual.
Okay, so this is basically the same thing that you guys just did. And these are the lowest terms that you could do when you divided each of them by that same common factor.
And the
Okay.
word, I'm sorry, did you have more to say? I'm sorry. Dilation.
Mm-hmm.
Actually, I don't think there's an A there.
No?
I think it's just D-I.
Dilation.
Dilation. So let me just show Muhammad one more thing, if you don't mind.
Mm-hmm.
That's a great visual. This is our original triangle. So what would you say of the original triangle compared to the new triangle, Muhammad? What's the comparison you can make? You have a statement? From the blue to the black? What happened?
The figure enlarges.
Yes. And in this case, it didn't enlarge, it kind of reduced.
Mm-hmm.
Okay? And you know what? If you want to see a dilation in person, go in the bathroom, look in the mirror, then turn the light off, and then turn the light back on. You'll see the inside of your pupil dilate.
Mm-hmm.
It'll go like this. You'll get that wasn't the best, but try it yourself at home, and that's a great job, Muhammad. I'm really proud of the guy. Do you want to try a challenge with Miss Walters here?
I also have one more question. It's about scale factors.
It's about what, honey?
Scale factors.
Scale factors, okay. What's your question?
Because, like, I already know the scale factor will determine how much larger or smaller the object will become.
Okay.
Like, how does, like, if a scale factor is greater than 1, what will it do?
Well, what do you think is going to happen? If you had a picture and you wanted to make a copy of it and it was just 1, okay? You just put it on a copy machine and you made a copy. That would be the same size, right? But if it was greater than 1, what do you think would happen to your picture?
It will increase.
Right. It would get larger, wouldn't it?
Increase is a good math word, right, Miss
Yeah, it is.
Walters?
I like that. I like that. Very nice.
I'm just curious.
I would like to try challenge 24 now.
Oh, wow.
Okay.
Well, he gets his name in the treasure chest one time.
Yes, he does. Oops. Wait a minute. Where is our? Here it is. Here's our secondary one.
Oh, boy.
All right. This is Muhammad. Muhammad, which letter would you like? A, B, C, or D?
D.
D as in David?
Wow. He's going for the big time.
All right. I like that.
8, 8, 5, 2.
A challenge. 8, 8, 5, and 2. All right, Muhammad. Take it away. Muhammad? Are you there?
Yeah.
Okay, let's work it out. Tell me what you want to do first.
8
Mm-hmm.
times 5.
8 times 5 equals?
40.
Yes, sir. So we've done that, and we've done that. Now what?
40 divided by 2.
40 divided by 2 is equal to?
20.
20. You still have this 8 left over.
Oh, boy.
Remember, our aim is to get to 24.
Okay, can I work it out and then call back?
Sure, you can work it out and call us back, Mohammed. That shows perseverance. We love it. That is math standard number 1.
That's true.
Perseverance.
That's right.
You can do it.
Don't give up. Keep trying.
All right. Good job, Mohammed. Thanks for calling.
He really knows his stuff with dilations. How about our next caller? Do you want to get that? Aaliyah came back to us.
Is that Aaliyah?
Oh, my goodness. She's back with us.
Hi, Aaliyah.
Hi.
All right. I don't know what happened before we lost you. So sorry. You had a question about fractions?
Can you say it again?
Did you have a question about fractions?
Yeah.
Okay. What was your question?
It's 4 campers need to share 7 gallons of water equally. How many gallons does each get?
Okay. Can you tell me that one more time, Aaliyah?
Okay. 4 campers need to share 7 gallons of water equally.
7 gallons of water?
Yes.
And 4 people?
Yes.
Okay. And you want to know how much water each person would get?
Yes.
Okay. So, how do you think we should go about working this problem out?
7 plus 4.
Okay, well, you don't want to add gallons of water in people, okay? If we want to evenly distribute this water among 4 people, okay, what operation do you think we need to do? I'm just going to draw 4.
Division?
Yes.
Excellent.
4 little happy faces. Okay, we're going to get some water. All right, and here is the 4, 5, 6, 7 gallons of water, okay? And when your teacher says, well, can you make a model? This is something that you could do. You could actually draw a picture. All right, so we're dividing 7 gallons by 4 people. So we know this person gets a gallon, that person gets a gallon, this person gets a gallon, this person gets a gallon, and then look, we have 3 whole gallons left. So what do you think we should do now? We know everybody's going to get at least 1 whole gallon of water, okay? Now what do?
We could cut the three other gallons of water into half.
Into half? Okay. We could do that. So that means this person would get half, this person would get half, this person would get half, and this person would get half. How about this one? What can we do with this last one?
Well, we could...
Remember how many people do... Go ahead.
We could divide it into 4.
All right, let's see. We can divide that into 4ths.
Pretty good.
Okay? So then each person would get one of these, okay?
Yes.
All right, now, I'm sure we don't want to know, okay. We know that they all get 1 whole gallon, plus a half a gallon, plus how much would each one of these be?
Half.
Well, it's broken down into 4ths, right?
Yes.
So how much would each person get from this 1 gallon?
1/4.
Correct. They would get 1/4. So it's 1 whole plus 1/2 plus 1/4. Okay?
Yes.
Do you know how to add fractions that have different denominators?
No.
No? All right. Well, let's take a look at this half. Okay? If I were to just break it into 4ths here, how many 4ths are contained in this half right here?
Could you repeat it?
How many 4ths? I broke this. Remember when we did halves? Well, I took the container that we had and I broke it into 4ths. How many 4ths make up this 1/2 right here?
How many 4ths?
How many 4ths
does each person get?
Well, from this this whole gallon here. Remember, each person got half a gallon. I just split it into fourths. How many fourths would 1/2 gallon be?
2/4?
Yes. So 1/2 is 2/4. And then I'm going to add the 1/4. It's going to give us 3/4. So each person will get 1 3/4 gallon now. I'm sure your teacher's probably is like, okay, well, how much is that exactly? Do you know how many quarts there are in a gallon?
There are, is it 3/4?
Actually, it's 4 quarts, okay? There's 4 quarts. 4 quarts, I'm going to abbreviate, equals 1 gallon. So, if I have 1 whole gallon and 3/4 of a gallon, this would be 3 quarts. So 1 gallon and 3 quarts. That might be too much information, TMI. But that's the way I'm breaking it down for you. Okay, so if you were to divide 7 gallons by 4 people, each person would get 1 3/4 gallons, or that would be the equivalent of 1 gallon and 3 quarts.
Oh, interesting. That's
Do
very
you want
cool.
to add something, Mr. Herman?
Well, all I wanted to do is ask Aaliyah, what grade are you in, Aaliyah?
5th.
5th?
Mm-hmm.
5th.
6th?
Oh, 6th.
6th?
5th grade.
6. 1, 2, 3, 4, 5, 6, right?
No, 5th.
5.
5th. So when you divide in your class, do you do decimal work or do you do remainders?
When you divide, do you have remainders of fractions, or do you do decimals? Do you break it down into decimals? Not sure? You want to show a decimals?
Yeah, let's go show you real fast.
Okay.
Okay, thanks.
Yep, you got to turn your TV down, Leah. Okay.
Okay. So we had 7 divided by 4.
Mm-hmm.
So I would just say to Aaliyah or any other grade. Oh, by the way, Aaliyah gets her name in the treasure chest one time.
Yes.
But, and I know Miss Walters knows this by heart, but what comes after the 7 if we have to add some more stuff on?
A decimal and a 0.
Outstanding. And I might just put 2 zeros in case we might need them.
Mm-hmm.
But the decimal's going to go straight up top, so 4 divides into 7. Oh, good. Aaliyah, you still there? Good. Stay with us, Aaliyah. We want to talk to you some more. 4 times 1 is 4. Aaliyah, can you subtract 7 minus 4? Excellent. 3. And then bring down the what?
0.
And 4 divides into 30. It doesn't go perfectly, but it does go
7.
7. And that's 28.
Mm-hmm.
Subtract, get 2. Now we're down to our last number because 4 does go into 20 beautifully. 5. And you know what? I think you said something about 1 3/4.
Yes.
And 1 7/500 is exactly equal from decimal to fractional at the same exact amount.
And you know what? Is that called a benchmark fraction?
You know more than I do. Why is it called benchmark? I don't know.
Because that helps us to compare fractions.
Oh, okay.
And decimals.
Okay.
Okay.
That's great. And I love what Miss Walters did as far as comparing gallons to quarts.
Mm-hmm.
And so it'd be 1 gallon and 3 quarts left over.
Just in case you needed it broken down like that.
There you go.
Okay. All right. Thanks for that question, Aaliyah. Your name has gone into our treasure chest because we treasure all of our callers here at Count on Us.
Mm-hmm.
All right. All right. We have another caller. Hi, who's this?
I think Muhammad's back.
Yeah.
Muhammad, you're back with us?
Yeah, I got the answer.
To the challenge?
Yeah.
Oh, I'm going to turn you over to Miss Walters. She's professional challenge maker.
All right. Let's see. We had the 8852.
Yep.
All right. Hold on one second, Muhammad. 8, 8, 5, and 2. And my earpiece is acting up over here. All right. Now, can you hear what he's saying, Mr. Herman?
I can hear it. Go ahead, Muhammad. I'll help you through a little bit. What's your first step?
Okay, first, you multiply 8 and 5.
Okay, so the 8 and the 5 are being used to get what?
40.
Excellent start.
And then you do, I'm going to put 8 and 5, I'm going to put the 40 on hold, so I'm going to do 8 times 2.
Hold the 40. Hold the mayo. Hold the cream cheese. All right, put the 40 on hold. And now what are you going to do? I'm sorry.
Sorry, I had something in my throat. Okay.
Okay. Now what?
Then you do 8 times 2.
Oh, that's where I was hoping you go last time you called. 8 times 2 is what?
8 times 2 is 16.
You're almost there.
Then you do 40 minus 16, and that equals 24.
We got a bing bing on that one, buddy.
Good job, Mohammed.
Muhammad, you did not give up. You came back.
He
Muhammad, you're the man.
persevered.
You're
got
the
his
man.
name? I'll put it in.
Oh, that's great.
Muhammad
Muhammad, way to
in
go.
again. Good
Oh,
job.
my goodness. Look who's calling in now. Okay.
All
Well, we
right.
got more people coming from Templeton. I think you know Templeton pretty well.
Hey, hold on.
Hold on.
We have to
Hold
go
the
to a
40
break.
and
Well,
hold
we
your
have to go
TV
to a break.
sets and come back to us after our short break.
Yes,
and we'll have some more Count on Us.
All right, see you in a few.
Hello, my name is Shayla Tucker from Stephen Decatur Middle School from 6th grade. I'm here with your email corner for today. Here's our problem. Judy has 8 candy bars. She wants to give 1/3 of a candy bar to everyone in her class. Does she have enough for all 24 students? We already have our diagram divided into 3 pieces, so now we can count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we have 24 pieces. And now for our numerical expression, we have the total of candy bars, which is 8, divided by the parts that are shared, which is 1/3. So we make our fraction, which is 8 divided by 1/3. Now we have to find the reciprocal, and we have to change 8 to 8 over 1 because we have to make this a fraction, times 3 over 1 because that's our reciprocal, which equals 8 times 3, which is 24, and 1 times 1 is 1. So our solution is she has enough for all 24 students to have a piece. My name is Shayla from Stephen Decatur Middle School with our email corner for today. See you next time.
Simple moments are what make every day count.
When I was a kid, I dreamed of being a stuntman.
I went from dream to dream pretty quickly. I wanted to be a cowboy. Tom Cruise in Top Gun.
I dreamt of being a nun.
Actually, before that, it was Popeye.
Malaria kills more than 2,000 children a day.
Text NET, N-E-T, to 85944 to make a $10 donation to Malaria No More.
Oh, messaging and data rates may apply.
Let's make malaria no more.
my goodness. Welcome back, because you did come back to us. Yay. You didn't change your channel. You stayed with the best show on TV, because we're Count on Us.
Yes, we are.
I'm Ted Herman, and still Miss Walters did not give up on me yet. She's still here working the problems. And how things going at Templeton lately?
Things are going great.
Really?
Mm-hmm.
I see there's a lot of learning going on over there.
A lot of learning going on from our pre-kindergartners all the way up to our 5th grade students.
Oh, my goodness.
They're doing
you
awesome.
Go to 5th?
Yes.
And then 6th graders someplace else, middle school.
Yes.
Very interesting. Well, I think we had a caller out there from Templeton, but I don't know if they're still there with us.
Hi. Who's
Hello?
on the air?
No one.
Oh, no one. Oh, my goodness gracious. I thought we had someone.
Oh,
we got
somebody's
somebody
playing
here.
games. Oh, Kettering Middle.
All right.
Oh,
sounds like
is that-
something for you.
I'll look at this. Is this John?
Yes.
Hey, John, how you been?
Yes.
That's a good answer. And how's Kettering Middle doing over there? Isn't Kettering Middle right down 202 or Central Avenue? Good. And what grade are you in?
John, are you with us?
You're not one of my relatives, are you, John? You're not trying to make me... What grade are you in, John?
7th.
7th. And give us a 7th grade question, John. Go ahead.
Negative 76 minus 36.
Oh, negative 76 minus 36. So what are these numbers called? Do you know what they're called? A special name for them?
Integers.
Integers. John, you know your stuff, buddy. Who's your math teacher over there at Kettering Middle?
Miss Brady.
Well, tell her a shout out next time you see her tomorrow that we're really proud of your skills so far. Now, here's something I like to do with my students when I teach. They're both negatives in a sense, but I'm going to keep the first number just the way it is. I never mess around with the first number, but this is really subtracting a positive 36, okay? So we're subtracting a positive, and what we can do is, well, watch, I'll show you what we can do. I'm going to put my minus sign here on my finger and the plus sign here on the other finger, okay? But on the back, I'm going to go opposite. I'm going to go plus here. I hope I can get this off. This is not permanent marker, is it, Miss Walters? Because when I get home, it's going to be a mess. So here I go. I got minus a positive number, and then I flip it, flip it. All you got to do is flip it. So now I'm going to add a negative. So you go ahead and tell me, John, what am I going to put between these two now?
Positive.
Yes, I'm going to add. And then what goes in front of the 36?
36.
Negative, right?
Yes.
So now we're actually adding those two together because they're both the same sign being added together. So what is 76 and 36? Let's do that together. 6 and 6, John.
12.
Excellent. We'll do it to 1.
On top of the 7.
Uh-huh. And 7, 3, and 1.
11.
Outstanding. And what sign do I put in front of the 112?
Positive.
Really?
Negative.
That's the other one. You had 1 out of 2 possibilities. Let's do this again. I want to make sure you're totally clear. Why is it negative 112, not a positive?
Because the bigger number is a negative.
And the other number is still a negative, too. So we're going to add them both together and make a bigger negative number. Negative what? What's the answer?
Negative 112.
Outstanding. You know what, John? You got your name. Even though my fingers are all blued up or whatever color it is, you got your name in the treasure chest. Do you want to try a challenge while you're on the air?
Yes.
Which challenge did you want to try?
The 24.
Oh, I love that challenge. Miss Walters is so expert at that, John. Nice job. Name in the treasure chest.
Hey, John. Which challenge would you like to do? We have A, B, C, or D?
B.
B. All right. So the numbers are 7, 1, 5, and 4. Okay, tell me
luck,
what
John.
to do. You put his name in?
Yes, you already got his name in once.
All right, come on, John. Tell me what I need to do.
7 times 4.
7 times 4.
Mm-hmm.
What's the product?
28.
All righty. And now what? I have a 1 and a 5 left.
Minus 5.
28 minus 5?
Yes.
Whoa.
It was going to give me how much?
23.
All righty.
I'm getting the bell ready.
And then what?
23 plus 1.
23 plus 1 is equal to
24.
24. Good
John
job.
got his name again. I'm proud of John.
Good job,
Kettering
John.
Middle. Represent.
All right, so your name goes in our treasure chest not once, but twice.
So he doubled his chances of winning. Wow.
Yes, he did. I have a quick question, Mr. Herman.
Yes, ma'am.
So, with the problem that John did, thank you, John. With the problem that John did, it was negative 76 minus 36, right?
Right.
So, because it's minus, you're going to the
Left.
to the left.
To the left.
So I could have
We got
gone.
Beyonce in the studio. In the left, to the left, to the right.
36.
Oh, yeah, right. Oh, I get it.
To the
You're
left,
going
to the
negative, down
Yes,
further
I
down
am.
negative number line.
Yes.
Beautiful job. So that'll give you negative 112.
Yeah, I was just wondering. Just
No, you were wondering right. You're
Okay.
wondering right.
Okay.
You're a wonder. You're a wonderful person, too. Okay. And I'm on my best behavior today. I'm so proud of myself.
He is. He's been really good.
Because I want to come out looking sharp today. And our next caller, I think it's your turn, was Zeta or somebody. I'm not sure.
Is that Zeta? Hi, Zeta.
Hey.
Hi, how are you?
Good.
Good. What school do you attend, Zeta?
Highsville.
Forestville, Forestville High School?
Highsville. Oh, Highsville, Maryland.
Hyattsville Middle.
Hyattsville Middle School?
I mean, middle school.
Yeah, Hyattsville Middle. Did you used to go to Mount Rainier?
Did you used to go to Mount Rainier, Zeta?
Yes.
Oh, okay,
I
yes.
thought I recognized your name. Good to see you again, Zeta. Well, I'll let Miss Walter take care of you now.
Oh, gosh. My earpiece came out again. Hold on a minute, Zeta. Mr. Herman?
Yeah, how do you spell Zeta? Z-A-I or Z-A-D?
Z-A-D-A.
Very nice. And you're in 7th grade at Hyattsville Middle. Well, go ahead and give us a 7th grade problem, Zeta, so we can get your name into the treasure chest.
Okay, Zeta.
She's ready for you.
15x.
16x.
Subtracted by 3y.
Okay.
Plus 2.
Mm-hmm.
Subtracted by 3z.
Subtract 3z. Okay, you got to turn your TV down because I'm getting feedback. So do I have it so far? 16x.
Plus 10. Oh, some more to it.
Oh, plus 10.
Subtracted by 4y.
Subtract 4y. Is that it?
15. I mean, subtracted by 15 is more to 4y.
Subtract
Subtracted by 15.
Okay, it's not subtracted by. Just subtract 15. Go ahead.
X. 15x.
Oh, 15x.
Goodness gracious.
Yeah, really.
Plus 7y.
Plus 7y.
Plus 3z.
Zeta, is there more to this problem, or are you done?
Huh?
Are you
Is
finished?
that it?
Yes.
That's the whole problem? Okay, I think Miss Walters is recording this beautifully in one big, long line. And what are you supposed to do? What's the goal of this problem, do you know? What are you trying to do, Zeta?
I'm trying to, I have to find the expression of it.
Yes. You ever heard of CLT? What's CLT? Combine like terms. I'm going to turn it back over to Miss Walters, and she'll show you how to bring this together.
All right, it's a little neater now. I have
Much nicer.
Have neat.
That's amazing how you did that.
Neatness counts with me. It keeps me organized. Okay, so we're putting together the common terms, yes?
Yes.
All right, so what do we see here that looks similar? And are there any parentheses or anything around any of these?
There's a lot of X's.
Okay, there's some X's. So we have a 16X here. Any more X's here? Boom.
Oh, yeah, 15. Yeah.
And we have minus 15X, yes?
Yes.
Excuse me. So how much would that give me? 16X minus 15X would give me?
It's 1.
Yes. Or 1X or just X. Okay.
1X.
All right. And here we have negative 3Y. Any other Y's? Oh, yes.
Oh, look at that.
We have negative 4Y. And we just did a problem very similar to this. Negative 3Y, I would say, plus negative 4Y would give us what?
1. 1Y.
Actually,
negative 1Y.
not negative 1Y. It would be negative 7Y, wouldn't it? Because you have negative 3 and you're taking 4 away. So when you take away, you're going this way to the left. So it will be 3, 4, 5, 6, 7. So that's 7Y. Okay? All right, so what's next? We have a positive 2. We have 10. 2 plus 10 is going to give us?
12.
All right, moving right along.
I'm sorry, there's another Y to deal with, too.
Oh, my goodness. Oh, my goodness. Thank you, Mr. Herman.
That's
This
why
is
I'm
so
here.
long.
Okay.
Negative 7Y, and we have plus 7Y. So what's going to happen to this? You have a negative 7 and a positive 7. What is that going to do?
I think it's gonna.
I'm listening.
I'm not sure.
Okay. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7. So for each of these pairs, this is how I did it with algebraic thinking. If we can make a 0 pair, okay? We have negative Y and a positive Y. So this is a negative pair, and they cancel each other out. There's nothing left over, is there?
No.
It's 0. So they cancel each other all the way out. Okay? So we did
So it's
this.
0Y?
Yes. So if it's 0Y, you don't have to put anything, do you? Because anything times 0, any Y times 0 is still going to be 0. Okay? So Mr. Herman is crossing out everything that we've done thus far. This and this. And so what do we have left? We have negative 3Z and a positive 3Z. So what's going to happen there?
3Z and 3Z is going to come together to add?
It's going to cancel each other out just like the 7s did, right?
Yes.
Okay, because this was the positive 3. And these are the negative 3. And you're making 0 pairs. You have nothing left, right? So let's see what we have. After all is said and done, we still have our X. And we still have our positive 12. So,
okay.
That's
it. But Zeta, can I ask you one question? Zeta, you still there?
Yeah.
Suppose you had negative $3. Let's say you owed your parents $3 for something you borrowed from them. But then you went and got some chores done, and they gave you $3 back. Where would you be? Would you owe them any money anymore?
Oh.
If you owed them $3, well, I think your brother or sister's very excited about this problem too. But if you owed them $3 and then they gave you $3 for doing chores, do you still owe them money?
Yeah.
You do?
Can you repeat the question?
Okay, you owe your folks $3.
So yeah, you was like, oh Mom, can I please get the let's see, those headbands at the store? And she gave you $3. And then you're like, oh, I don't like owing anyone any money. I'm going to do some chores.
There you go.
So your mom said, okay, can you please, can you wash the car for me? And you're like, okay, Mom. And you earn $3. It's a small car. You earn $3, okay? So instead of saying, okay, Mom, can I have the $3 that you owe me? You're like, well, I owe her $3, so Mom, you just go ahead and keep those $3. And now I don't owe you anything.
Ah, you're even again.
Okay?
Cool.
Yeah.
That's like a real world connection to negative integers and positive integers, okay?
And you got your name in the treasure chest.
Oh, yes, your
Did
name
you want
is
to
in
try
our
a
treasure
fast
chest.
challenge before we pick our winners today?
You want to try a challenge? Zeta?
Yeah.
Okay, take a look. Which challenge card would you like to do? A, B, C, or D?
B.
B?
B.
Did you say B or D like in dog?
B like in ball.
Oh, okay. All right, we got 2 minutes, so let's quickly. 7, 1, 5, and 4. Now, we've already had one solution. Let's see if you can give us another solution to this. Go ahead. You think you need more time?
7 times 5.
7 times 5. 35. Okay.
And 4 times 1.
4 times 1 is 4. Okay, now remember our target is 24. Okay?
So that's not
But
going
that's
to work
okay.
out.
That's
But
okay.
good try.
Zeta, you still got your name in our treasure chest because we treasure all of our callers.
Whoa,
and
nice
we have to
segue.
pick a caller right now
And
for
Miss
our
Walters
drawing.
is so lovely. She gets to pick out the name today.
Let's see. Thanks for calling in, Zeta. Let's see who the winner's going to be. The winner is Mohammed.
All
Mohammed.
right. Way to go, Muhammad. And all our callers are great.
Yes.
And make sure you always call us back on Mondays and Wednesdays because you can always count
on us.